Graph paper. I'm not going to use graph paper. I'm going to use regular old drawing, rough sketches here. Because what I want to be able to do here, bless you, what I want to be able to do is I'm going to be creating these regions, and I'm going to figure out the points at which they change, where the two lines intersect, things like that. Now, these intersections and things like that, we've done that algebra already. We did that algebra when we did solving systems of equations. So what we do in linear programming is we look at a list of inequalities, basically, and we sketch it. And we try to figure out where the intersection of all the inequalities occur. So right off the bat, when you're looking at a problem like this, I've got x is greater than or equal to 0, y is greater than or equal to 0. What does that tell us? It's a first quadrant problem. Do we agree on that? Okay. So I know this is going to be a first quadrant problem just by the first two constraints. Now, from there, I'm going to do my quick graphs. Okay? I'm going to do my quick graphs. So on the first one, I have a y-intercept of 5. Do you agree? Okay, I have a y-intercept of 5. Yeah, it's about here. Oops. But I have an x-intercept of negative 15. Which really doesn't help us very much for being in the first quadrant, does it? What's that? Solve for x?
Wait, how do you know?
X is greater than 0, y is greater than or equal to 0. So I'm looking for all the shaded region that goes in the first quadrant. So what happens sometimes is that it might be behind it, so you just draw it and extend it, because we know it's still going this way. Okay, just draw it like that. We know it's going to look like that. Okay. And now you just ask yourself, for when you're looking at a test point, is 0 plus 0 smaller than 15? Yeah. So it would be everything shaded below that. Now, I'm just going to draw some arrows like this. I know that it's going this way, and I know it's going up as well. These arrows are kind of chomping into the where you want it to be. It's like teeth. And then I do the same thing for the next one. I have a y-intercept at 12 and an x-intercept at 6. And I connect. And once again, is 0 plus 0 smaller than 12? Yeah? So what we've just done is we've created this bounded region in here. Everybody agree with me? Yeah. If you look at that, how many points are there of where the lines change direction?
4.
There's 4. Okay? There's one at 0, 5. There's one at 6, 0. There's one, it happens to be at the origin, at 0, 0. And then there's the fourth point is the intersection of those two equations. Now you just have to use what we did in solving systems to figure out what that coordinate is. So there are multiple ways to set that up. In this case, I might just multiply the top equation by 2 to eliminate the variable of x. Do you agree with me on that? Bless you. If I multiply the top equation by 2, I get negative 2x plus 6x is 30. I'm going to add these together. I get 7x is 42, x is 6. I'm using elimination with systems of equations like we did last week. Thank you. I can't remember what day it was. Oh, thank you. Thank you. It's y. So 7y, so y is 6. Okay? If y is 6, what's x? 3. Very good. Everybody see how I was able to do that real quick? You substitute 6 in for y. 6 divided by 2 becomes 3. So this ordered pair occurs at 3, 6. So what we're going to be doing today is we are taking basically all the stuff that we've done so far in chapter 3 and put it into one giant problem. Okay? And then tomorrow we put that giant one problem into a word problem. Okay? And we learn how to create charts and how to put things together, what words mean, and then we turn it into a simple problem like this. So, the goal today, again, is to figure out maximum and minimums. Now, I didn't figure out anything about a maximum and a minimum yet here, did I? Because there isn't anything given to you to maximize. And that's where the next term comes in. The next term that we talked about is this value of C. These problems are going to have a C equals something. That's the function that you want to find the maximum or the minimum for. It's a constraint. What are you trying to solve for? The problem will give that to you. They will say, I want to maximize profits. I want to maximize this. I want this equation to find the greatest value I can for this and the smallest value that I can for this. So if that was the case for these sets of ordered pairs, and I wanted to find what the maximum value was, I think it was what, C was x minus y? Yeah. What I would do then is take these values of x and y and substitute in C, which gives me the largest and the smallest value. And that allows me to find the maximum and the minimum of this graph, according to this function. What's that? Well, I don't know. I haven't done it yet. So if you did it that way, you'd have, let's see, that would be 0 minus 5, 6 minus 0, 0 minus 0, and 3 minus 6. So the maximum, that's negative 5, 6, 0, and negative 3. Where did my maximum value occur? 6. At 6, 0. This would be my maximum. And then where would be my minimum? And that's my min. I'm glad you're paying attention. I was testing you. No, I wasn't. I just didn't put that. And that's kind of what you do. So what we're looking at doing is, as we build into these word problem styles, you're going to be able to maximize profit on selling two different items. You're going to maximize floor space and storage space. You're going to be able to figure out where things go into. These are problems that kind of encompass everything you've ever learned about math. These are real good thinking problems. So let's look at another example. In this example here, let me get rid of my graph paper again. Find the maximum and the minimum of the objective function, that's that C function, subject to the following constraints. I try to use the lingo the book does. Oops, try to blow that up for you. That way you kind of get used to the vocabulary that you're going to see. You're going to be given that constraint function, that objective function, C equals 3x plus 4y. Every problem's a little bit different. In this case, you have three constraints. X is greater than or equal to 0, y is greater than or equal to 0, and x plus y is less than or equal to 8. So, like I said before, you always start by graphing everything first. Once again, in this case here, it's a nice and easy first quadrant problem. Do you agree? Yeah. I know it's going to be a first quadrant problem because it's x is greater than or equal to 0, y is greater than or equal to 0. And now I have x plus y is less than or equal to 8, which sets us up for using quick graphs. What are your intercepts? 8, 8, 8. Nice when it's easy like that, isn't it? And now I have to figure out what side to shade that. Do I shade it going inward or going outward? Inward. So now I have to find that third point. 0, 0. So now you have 3 ordered pairs to find the maximum and minimum off of that.
Why was it 0?
It's at the origin. It's bounded within the first quadrant because x is greater than or equal to 0, y is greater than or equal to 0. So since that means it's stopped, this is the smallest value of x and y can be. Okay. And now it's just a matter of substituting in 3 times 0 plus 4 times 8. 3 times 0 plus 4 times 0. And then 3 times 8 plus 4 times 0. Which one gives you a maximum and which one gives you a minimum?
0, 0.
0, 0 is the minimum.
0, 8 is the max.
That's 0, so that's my min. That's 32, and that's 24. Last time I checked, that's bigger. And that's all you gotta do. What do you mean?
Because you said last time you checked it.
Alright. Sometimes I'm not that bright.
What about, I thought the function was x minus y.
Each problem for that is going to be different. They're going to, for each problem, they give you a different value for that objective function, and it just depends upon the problem. Like I said, tomorrow when we get into the word problems, it's going to say you make $8 profit on shoes and you make $6 profit on socks, and you want to maximize your profits. So your objective function would be 6 or 8x plus 6y. You create that depending upon the problem. Today, it's all basically stuff that you're looking at right here where you're given a list of constraints. You're going to plot it to find those points. Tomorrow, it's words that you have to create the equations from. Oh, don't give me frowny face, you'll be fine. I haven't steered you wrong yet. All right, try this one. Let me pause this up, give you guys a second to try it. Remember, x equals a number is always a vertical line that goes through that number. So I got a vertical line through 2. And it says there are numbers that are greater than or equal to 2, which means I got to go to the right. Okay? And then I'm bounded up the other side by x is less than or equal to 5. So I just draw another vertical line at 5, and I'm going this way. Okay? So far, so good? The third one tells me that it's all values of y that are greater than or equal to 0. So that means I no longer have to worry about down here. I know I'm going up from here. So right now, I have an open rectangle. No top on it. What's in the bottom? Thank you. We understood that. And then from here, it's just a matter of drawing through. So I know that I'm going to have a y-intercept of 12. Do you agree on that?
Yeah.
Okay. I know I have a y-intercept of 12. But now when I worry about my x-intercept, what is it going to be? 6. Everybody agree? Everybody see where I'm getting 6? In order to get my x-intercept is when y equals 0. So if I set it equal to 0, I get negative 12 is negative 2x. I get 6 for my x-intercept. Okay? It wasn't set up in that standard form, but by just moving some stuff around, I can figure out the x and y intercepts relatively easily. So I can still do a quick graph. That way I don't have to try and walk my slopes. So I know that I have an x-intercept over here at 6. So this is going through here to here. All right? Now, you test it. Is 0 smaller than 12?
Yeah.
Yes. So right now, we've created this 4-sided figure with these 4 points. Everybody see that? 2 of those points are very easy to find. They're on the x-axis. So I have 2 points. I'm going to erase this, get this out of the way for a second. 2 points I have are at 2, 0, and 5, 0. Now I had to figure out the ordered pairs here and here. And since those guys lie on vertical lines, what's the value of x there? 2 and 5, right? So I know x here is 5 and x here is 2 because they're on a vertical line. To figure out what the y value is, all I gotta do is substitute in. What's 5 times negative 2? What's negative 10 plus 12? 2. So with one ordered pair at 5, 2.
What are you substituting into?
The equation, because this is the equation of the line that it's intersecting. So I'm paying attention to which intersection is going through. And then the other one I substitute in positive 2. So I get negative 4 plus 12, you get 8. You found that by doing it that way, you're able to find those 4 points that the constraints intersect with one another. You created this shaded boundary. Those boundary points are what it's changing shape at. Where is it changing direction? At those points are where your maximum or your minimum values will occur. So now it's just a matter of going back to he wants to find the maximum value of our objective function. So I take it. Well, what's negative 2 plus 3 times 0? Negative 5 plus 3 times 0. Negative 5 plus 2 times 3. And negative 2 plus 2 times, oh, excuse me. I got lost in my letters here. 3 times 2. And this is 3 times 8. So when you solve each one of those values, you get negative 2, negative 5. You get 1. And then the last one you get 22. Double duck, quack, quack. You've never played bingo. When they say I-22, you always say double duck, quack, quack. No, it's I-22. There's no Y in bingo.
Why do you say 22 plus 5?
It looks like ducks.
That's the stupidest thing.
Nobody likes you. Get out of my classroom.
I don't get it. Like, it doesn't look like a duck to me.
Can you draw it
Looks
again?
like a swan.
How the duck-
No. No, because now you're all going to make fun of me.
No, I won't. I want
Whatever.
I just want you to.
Wait, what?
Anyway, so where's our maximum value?
Wait, when you said
Let's try another one. So, like I said, in this problem here, it just asks you to find the maximum. The maximum value occurred at 2, 8. So your maximum value is at 2, 8. Yes, sir?
Can you go over one more time, like how do you get the other 2 points, like you did some equation for like
Where they intersected? What I'm doing here for this, to find the intersection, what the coordinates there, I have to figure out what the intersection is of those 2 lines. I know one of those lines is the equation x equals 5, and the other equation was negative 2x plus 12. So since this is a vertical line, I know that the value of x is 5, and all I do is just substitute in and figure out the y value. Same thing on the other. Now, when we get into some, they're not always this clean with their horizontal and vertical. Sometimes you actually have to do some real math and solve it through. Okay? Try this one. So once again, we want to find the maximum and the minimum of the objective function, which is x plus 5y, with the following 3 constraints. X is greater than or equal to 0, And then the two inequalities of y is less than or equal to 2x plus 2, and 5 is greater than or equal to x plus y. So as we start to plot these things out, I know that by looking at this problem, I'm going to have, what is it? Everything's going to have to be bounded either within the first and the fourth quadrant. Do you agree on that?
Yeah.
X is greater than 0 only occurs in the first and the fourth quadrant. Since there's no bottom to it, it's not telling me to stop at any y value, so it could occur anywhere in this region between first and fourth. So I know right off the bat, I'm kind of looking at a problem like this. I'm only really worrying, from that first constraint, I'm only really worrying about first and fourth. Now, after that, I go to the, do you guys agree that I have a y-intercept of 2 on the second one? And what's your x-intercept on that?
4, -4.
Yeah, if you cover up here, it's be at -1. Your
Yeah,
x,
because you minus 2.
yeah. All right, so your y-intercept is at, or your x-intercept is at -1. Well, that's not really helping me because I'm already saying it's got to be greater than or equal to 0. You agree? It doesn't matter where it is back this way, but I wanted to make sure that I continue it, that arrow going up, though, the other way. Because all you have to have is 2 points to determine a line. Well, we just did.
Wait, how'd you get 9?
What I did to get my x-intercept, remember you set y equal to 0? So if I set y equal to 0, I subtract 2 and divide by 2, I get -2. Okay? And then lastly, we have x and y intercepts of 5. And now I got to worry about my shades. Is 0 smaller than 2?
Yeah.
Yes. So it's going this direction. Is 5 greater than 0?
Yeah.
Yes. So it's going in this direction. So my region is, once again, those 4 spots. Yes, sir.
Wait,
Or does it continue like this?
Whoa.
Is there a bottom to this?
No.
No bottom to this. Will this have a minimum value? No. It's a bottomless pit. Ozzie Smith fell into it and he's just taking pictures. I thought I heard a couple of shuffles because of the Simpsons reference, and then I hear who's Ozzie Smith.
I
So,
don't know.
all right, that's okay. So what happens here is, do we agree that there is no minimum value? Okay, it is unbounded. There's no minimum. There's no min. But we can still possibly find a maximum value. The only points that are going to help us are going to be here and here. Because does it change direction at this spot, at 5, 0? No, but it does change direction at 0, 2. It goes that way. All right? I don't even have to worry about checking it at the origin because it doesn't change any direction. It's still just falling there. There's only 2 points you have to worry about. We know one of them at 0, 2. So now I just have to figure out where those 2 lines intersect. So using what you did with systems of equations, you can set it up rather easily. I know that y is 2x plus 2. So 5 equals x plus 2x plus 2. All I'm doing is using direct substitution. I took this first equation, y equals 2x plus 2, and I'm substituting it into the second one. 5 is x plus y. 3 is 3x. 1 is x. If x is 1, what's y? Very good. So this ordered pair is at 1, 4.
Are you allowed to just look at it and say it's 1, 4? Is that valid? Is it
You have.
on B or B or C?
Well, I don't want you to graph them up. That's why we're going to do these by hand. Because it's a very inaccurate way of doing things. It just, I mean, you have to be real precise to make sure it is perfect. What's that, Sonner?
If you followed slow, I'm sure without it.
There are many, when we do systems, there's a couple of ways of setting these things through. So all you have to do then is just substitute in, figure out which one gives you the maximum. Is it 0 plus 5 times 2? Or is it occurring at 1 plus 5 times 4? It's going to occur at 1, 4. Your maximum value is 21, and it occurred at 1, 4. Okay. Are your heads spinning?
Yes.
Yeah. Can you go through finding 1, 4?
How I found 1, 4 is I found the intersection of these two equations. I took those two equations, y equals 2x and the other one was 5 equals x plus y. Shh, ladies and gentlemen, hold on. By doing that, when I'm using and I'm finding the substitution or elimination methods of solving systems, when you're trying to find the intersection of those two lines, just disregard the inequality symbols when you do that part. The inequality symbols are helping us find our shaded region area, but when you go to solve where they intersect, don't worry about it. Just set them equal to each other. And right here, I'm seeing that I can use substitution because y is 2x plus 2. So I take 5 is x plus 2x plus 2. And I set it up that way. And that's how I got 1. Does that make more sense?
And then a lot, right?
What's that?
And a lot, right?
See. Let's see the move your target. Here's what I want you to start for tonight. Oops, wrong button. Try those. This is section 3.4. 12 through 20. They're constraint problems. Don't use graph paper. Rough sketching. Exactly. That's exactly what they look like. Okay?